Everyone, this is Algebra 2. This is Unit 6. We're talking about quadratics. And this is Lesson 5. And we're going to be looking at how to factor and how to solve special products. Okay, so there's a couple of special products when we're looking at quadratics that if we can recognize them, right, as these special products, it makes factoring, it makes solving a whole lot easier. And so we want to look at those today. So first of all, our goal is to just recognize those, right? What are the properties of those special products and how can we identify them? And then the second thing is how can you use those to your advantage? So the two special products that we're going to look at here are, the first one is called the difference of squares. And so if I look at a quadratic equation and I see that the first term, right, the quadratic term of that is a perfect square. Okay, so this could be x squared, it could be 4x squared, it could be 9x squared, 16x squared, 25x squared, right? And any number that's squared and the x squared. And then the last term is also a perfect square. The last term is also a perfect square. Then that factors out to be the square roots. So it's the square root plus the square root and the square root minus the square root. The square root of the first term plus the square root of the second term and the square root of the first term minus the square root of the second term. So for example, if I have the polynomial, let's go x squared minus 64. Okay, and let's actually make this a little more interesting. Let's say that this is 9x minus 64. Let's make it 16x. Okay. All right, so if I look at this, right, I can see, well, I've got some perfect squares here. I've got 16 is a perfect square, x squared is a perfect square, and 64 is a perfect square. There's no middle term, right? It's only two terms, and I'm subtracting. Okay, so those are the three things we're looking for. This difference of perfect squares. So the way that that factors out is, well, I take the square root of 16x squared, and that's going to be 4x. And the square root of 64 is 8, so I'm going to have x plus 8. And 4x minus 8. So very simple to factor out if we can see that pattern in there. Okay, I've got a perfect square in the first, I've got a perfect square in the last term. There's no middle term, and I'm taking a difference. The second one we're going to be looking at is what's called the perfect square trinomial. Okay, so again, that first term, right, that first term is a perfect square. The last term is also a perfect square. And then my middle term is where it gets a little bit tricky. So what I have to look at is I have to look at the square root of the first term and the square root of the second term. I'm going to multiply those together, and I'm going to multiply them by 2. And if all that happens, then I know that this is just simply x plus b times x plus b. The square root of the first term plus the square root of the second term, all right, the last term, and then multiplied again, the square root of the first term plus the square root of the last term. And that just works out to x plus b squared. Okay, so let me show you an example of that. So if I look at this, so let's say let's go 4x squared. And let's say 20x and 25. Okay, so look at this first term, right? That first term is 4x squared. So that's 2x, right? 2x multiplied by itself. So it's 2x squared. And then 25 is 5 square root of 5 multiplied by itself. Okay, so I've got a perfect square in the first term, I got a perfect square in the last term, and then I just want to look to see, right, this is middle term, is it 2 times the square root of the first one times the square root of the second one? So is this 2 times 2x times 5? And it is, right? 2 times 2x is 4x, 4x times 5 is 20. So this is a perfect square. So what does this mean? It means that this is simply x plus 5, x plus 5 times x plus 5. Or we can say x plus 5 squared. The real trick is being able to recognize that. Once you recognize it, the factoring becomes fairly trivial. Sorry, this is 2x plus 5. The factoring becomes fairly trivial once you see that pattern in there. But the real trick is to understand and recognize that pattern. Let's look at some examples here. So we're asked to factor these quadratics. So here I've got a perfect square. Here I've got a perfect square. There's no middle term. It's a difference. This is a difference of squares. And so I know that this is going to be x minus 8 and x plus 8. Okay, the square root of x squared and the square root of 64. At this one, I also see that it's 2 perfect squares. 25x squared is a perfect square. 81 is a perfect square. And so this one's going to be 5x minus 9 and 5x plus 9. Okay. And it doesn't matter if I put 5x plus 9 first or 5x minus 9 second. It doesn't matter. They're still all being multiplied together. But the important part is to see that pattern. Okay, if we look at these now, so here I've got a perfect square. 16 is also a perfect square. So this is x, right, times itself. This is 4 times itself. And so the question is 8x 2 times x times 4. And so 2 times x times 4 gives me 8x. So this actually works out. This is a perfect square polynomial. And so this is actually x plus 4 squared. And the same thing with this one. This first term is this perfect square. It's 3x squared. The last number here is also a perfect square. It's 7 squared. And so the question is this middle term 2 times 3x times 7? And so 2 times 3x would give me 6x. 6x times 7 gives me 42. So yes, this is a perfect square. So this one would become 3x plus 7 squared. Okay, so the real trick here again is to recognize those perfect square polynomials. So how do we use these? So here's how we're going to use these. We want to find the zeros of this function. So remember when we talk about zeros, the zeros are the solutions, the x-intercepts. We use all those terms interchangeably. So what we want to do here is we want to find out where 9x squared minus 25 is equal to 0. So is that equal to 0? Well, I can see this is a difference of squares. And so I can see that this factors out to be 3x minus 5 and 3x plus 5. And when I multiply those together, I get 0. So my zero product property says that either 3x minus 5 has to be 0, or 3x plus 5 has to be equal to 0. So one of those two things has to be 0. One of those two binomials, right, has to be equal to 0. And so if I solve these, so if I add 5 to both sides and I divide both sides by 3, right, I end up with x is equal to positive 5 over 3. And likewise, if I solve this one, I subtract 5 from both sides, divide both sides by 3, I get x is equal to negative 5 over 3. Okay, so there are my zeros. So it's at 5/3, 0 is the first coordinate, and the other coordinate is negative 5/3, 0. Now, the interesting thing about this, right, is because that middle term is 0, right, if I were to find the axis of symmetry, that axis of symmetry would actually be 0, right? And it would also mean that my vertex also lies right on where y is equal to 0, right? Or where x is equal to 0, which means that my vertex lies on the y-axis. So my y-intercept and my vertex are actually the same points. So I can tell just by looking at this, and I understand how parabolas work, that this also has a vertex of 0, negative 25. Okay, so let's look at another example. Oops, I thought I had another example there. I lost my example there. So let's try this one. If I look at this function here, so if I want to find the zeros of this function, if I say, well, f of x is this, I want to find the zeros of that. Well, what I really want to find is where this function is equal to 0. Okay. So I know that that's a perfect square polynomial, right? It's a perfect square quadratic. Since I have a 3x, right, squared here and a 7 squared here. And when I multiply those together and I double it, I get 42. So I know that this is 3x plus 7 times 3x plus 7. Okay. And I could also say that's 3x plus 7, that quantity squared. But for the purpose of finding the zeros here, I'm going to use that zero product property. So I know that 3x plus 7 times 3x plus 7 is equal to 0. So that tells me that 3x plus 7 has to be 0. Okay? Both of these factors are the same, so I don't need to solve for 2 of them. I can tell right here that this is only going to have one x-intercept. And it's going to be where 3x plus 7 is equal to 0. And if I solve that, I get x is equal to negative 7 over 3. Okay, so this parabola will come down and only touch that x-axis one time. And kind of by definition, or just by logic, right, if it touches it at only one point, the only point it can touch at is the vertex. So I also know that this x-intercept here also represents the vertex of this parabola. Okay, so in this case, right, where I have the difference of 2 squares, I know that my vertex is my y-intercept. And when I have this perfect square parabola, I know that my vertex is the x-intercept, okay, because there's only one of them. All right, so I'm going to go ahead and end the lesson there. Take a look at the problems in the homework assignment, and please let me know if you have any questions. Thanks.